Hey, how's it going guys? And we are back. And in this video, we will be talking about section 2 of chapter 16. Some of the greatest achievements of the scientific revolution that happened during the 16th and 17th century were made in the fields that were previously dominated by the Greeks, like astronomy, mechanics, and medicine. Let's talk about astronomy! Now, this subject was mostly taken over by Ptolemy's geocentric system. Now, what that means is that the universe consisted of the planets and the sun, each of them being spheres, orbiting around the motionless Earth at the center, and it worked its way out. But not towards infinity, since beyond the 10th sphere, there laid heaven. Even if that ideology concorded with the biblical text of Christianity, since it followed the path that the humans were at the center of the universe, some did not follow the same path. So let's talk about Copernicus. Niccolò Copernicus, who was born in 1473 and died in 1543, was a Pole mathematician who found that Ptolemy's geocentric system was too complicated and that it failed to explain the motions of the heavenly bodies. He was not an accomplished observer and often relied on the data collected by his predecessors until he finally came up with the heliocentric conception, which was like a simplified version of the Ptolemaic system, or so he thought. Basically, this theory argued that the sun was the one that actually rested motionless at the center of the universe, while the other 8 planets orbited around it. What appeared to be the movement of the sun and the other stars was in reality due to the daily rotations of the Earth on its axis. It was all written in his famous book on the revolution of the heavenly spheres, published shortly before his death. So his new philosophy practically went and smashed Ptolemy's system right in the face and arose questions about Aristotle's astronomy as well as the place of humans in the universe. The Protestants who followed the Holy Scriptures word by word were not happy about this and attacked the idea first, especially Martin Luther, who claimed, and I quote, "The fool wanted to turn the whole art of astronomy upside down." The Catholic Church, though, remained silent during this period, but will have the occasion later to roar at the face of science. Now, let's go to Kepler. Johannes Kepler, born in 1571 and died in 1630, was a German mathematician and astronomer who also worked under the wing of Tycho Brahe, and without him, Kepler would have never been able to discover his 3 laws of planetary motion. He was very interested in Hermetic magic, which led him to write a book in 1596 about his theory on the universe being constructed on a basis of geometry, which then led him to study the music of the spheres. Now, on to his laws. Kepler published his first 2 laws in 1609. The first one contradicted Copernicus by stating that the orbit of the planets around the sun was elliptical and not circular, and that the sun was at the place of one of the foci and not at the center. His second law said that planets were faster when close to the sun but slowed down as they got farther away. This law actually went and destroyed a fundamental principle in Aristotle's astronomy that said that the motion of planets was steady and unchanging. Finally, in his third law, he explained that planets with larger orbits revolved at a slower velocity than planets with smaller orbits. His theories went on and disapproved the idea of a circular orbit and that the planets were not made out of crystalline. The Ptolemaic system had been totally destroyed and people were now free to think in new ways about their universe. But some questions still remained unanswered. What were the planets made of, and how did they move? It was an Italian scientist who responded to the first question. Moving on to Galileo Galilei. He was born in Italy 1564 and died in 1642. He was the first astronomer to ever use a telescope to observe the heavens. He made some pretty astonishing discoveries like craters and mountains on the moon, Venus's phases, 4 moons orbiting around Jupiter, and many more. He revealed his findings in his book called The Starry Messenger, published in 1610, which also talked about how other planets were made out of similar substances than of the Earth, thus proving wrong another traditional concept in cosmology once again. Now this book was the key to his fame after it stunned his contemporaries who now had a bigger picture of the universe. Everywhere he went, he was perceived as a conquering hero and was even offered a position in the court mathematician of the Grand Duke Cosimo II of Florence. Despite his fame, Galileo still had to deal with the Catholic Church, who was not happy about his discoveries that undermined the Ptolemaic system and supported the Copernican one. This new system not only threatened the scriptures, but also rose uncertainties about the place of humans in the universe if they were not at the center anymore. He was presented before the Roman Inquisition and was condemned to recant his theories. However, he was still allowed to discuss the Copernican concept as a mathematical supposition only. But Galileo had other plans. He continued on with his work, especially when he published another book in 1632 called The Dialogue on the Two Chief World Systems, Ptolemaic and Copernican. The book was available in Italian, which meant available to a wider public, and that angered the church even more. He will be summoned once again to the Holy Office in 1633, where he will be forced to revoke his errors and be placed under house arrest for the final 8 years of his life, where he will study mechanics. We finally arrive at Newton. Sir Isaac Newton was born in England 1642 and died in 1727. He was mostly known for his laws of gravity. He was also known for creating calculus, the mathematics that calculated rates of change. In 1669, he accepted a position in mathematics at the University of Cambridge. During his time there, he wrote his most famous book, The Mathematical Principles of Natural Philosophy, or Principia for short. In there, he explained and proved his universal laws of gravitation, and those very laws were able to answer one of the last questions asked in astronomy. Why were there movements in the universe? The answer was simple. Gravity. The answer was gravity. The implications of Newton's findings were huge, even though it took about another century until his ideas were accepted. Now, with these laws, intellectuals were now able to unlock all the secrets of the natural world, since it seemed to function like a sort of mechanism. Newton's world machine would seem to function according to the laws of time, motion, and space, and it dominated Western world view until the 20th century.